So yeah, welcome to our duo presentation. So my name is Stefan Spirk and I'm a professor at the Graz University of Technology. But today I'm talking to you basically as the CEO and co-founder of our startup Ecolyte, basically. So that we have just founded like last year, like in 2022. We have now 4 employees. We got now a huge EU project funded. And we started already quite 2 or 3 years ago in implementing the Safe and Sustainable by Design principles. I think the framework was not set back then, so we were just like trying to do things. Like we were really like setting up as good as we can. And I want to report a bit on one hand on the strategy that we were following, as well as the results, like really practical results. So you were showing something about the battery, and you were talking a lot about lithium-ion batteries. And what we are working on is a different concept, basically. So you're working like with liquid batteries, so redox flow batteries. Maybe you've heard about them. So currently there are the same problems that what the previous speaker was saying. So we have critical raw materials. They're basically vanadium, very toxic as well, non-available, cause a high CO2 footprint. And what we did in the last couple of 7 or 8 years at the university was we developed some processes. We made patents where we could replace the metal by organic materials. And these organic materials, basically, they come from lignocellulosic feedstocks. So there are a couple of startups also like in the Nordics who are like following this strategy. And our vision is really that we replace all the materials that we have in the battery, not only like the redox active materials that stores you the energy, but also the other ones that are very important for the functionality. I think you also mentioned the binder, which is, we don't need a binder here, for instance, but here the membrane that's at the moment made from naphthalene. It's a perfluorinated chemical, and it has a very, very bad environmental footprint. It's one, in the production of naphthalene, you create these forever chemicals, like this perfluorinated octanoic acids. So this is like the strategy that we have in our vision, and maybe that you just understand how works, or how does such a battery work, just that you see how that works. So we have like a separation of the energy that you store and the power that you get out of it. In a lithium ion cell, what you said, you have compressed everything in one thing. And that the problem is that recycling gets very difficult if you have so many components in a single cell. So here basically you separate the whole thing like in a fuel cell. So you separate the energy in the tanks and you pump the liquid through the electrochemical cell. And you get a lot of advantages basically based on that you don't have to take care of in such batteries. So we don't have any self-discharge, no capacity fading in theory. We don't have like problems to scale the batteries in terms of what does it mean? Making them very big for stationary storage, which we basically need. So that's the main problem we have in this energy transition, that we don't have the storage capacities, like in chemical, mechanical, physical storage, many ways. And for the lithium-ion batteries, it's really difficult to make them very big. A lot of things, I don't want to go that. And one of the other things is that you really have a very long lifetime. So that's maybe with second life that may change for lithium-ion batteries, but still I don't believe that the second life batteries will really make it into large-scale energy storage. So we want to replace that, and what we did basically in this research projects back then, so I'm coming from the Institute of Bioproducts and Paper Technology, really close connections to all these head of researchers in Central Europe. And we were thinking about, can we like use this lignin, like it's one of the components in the tree, to depolymerize it and convert it to something that is like valuable. And actually there is a chemical that you can make from this, and you probably know that. So maybe you don't know the chemical structure, but you know vanilla, right? So that's the flavor component of many products we like to eat, like ice cream, or in Austria we also have this vanilla Kipferl or vanilla croissant, very famous, so you should try. And yeah, so that was the idea, and the concept was quite easy. This was our starting material, and we could convert that quite nicely back then in this Angewandte Chemie paper in 2020 to show that this is working. You see, back then already we had quite good stability. So I think if you simulate this would basically be the operation of the battery for a year. Okay, you lose 12 to 13%, but that was in the lab scale, and that was like results from 3 years ago. We filed then some patents on it, and we really were checking how this technology could be also like working out. Basically, you see these were the small cells back then we were using. So, and this is what we're now doing in the prototyping. And I think that the basic way that you always have to think about a startup is, I'm standing here, you saw my first slide, I said sustainable energy storage solution. But you need to prove it, right? And already back then, when we were like talking to each other, Andreas and me, we were always thinking about how can we like check it, how can we improve it? And then these things got very, very important, like about the safety, like the value chain, the life cycle assessment, toxicity, and so on. And we both basically agreed that we need a systematic approach on that. And that neither me as a person who's working on materials research, nor the startup, because you don't have any research, we just need to get things going, right? So it's what you also said. It's like you need to be pragmatic. Yeah, what can we do? And finally, it was Andreas who had the idea of this SABATLE project, and I think he will now give you an overview about the next couple of minutes.
Thank you, Stefan. That's quite fine. Can you please? Thank you very much. Thank you, Stefan. That's a perfect introduction, of course. The project, Steff is the coordinator now of SABATLE project, which was our aim to address exactly what we are talking today, but nobody was talking about SSbD or double SBD. I like this wording. So we had to start from scratch more or less. So I take you now with a short time wrap some years ago. NanoRec project started with the SPD Saved By Design things, in which we were happily starting a so-called Galant case study in that. First time applying SPD to, in this case, in a glass coating project. So stepping forward from the theoretical approach to a practical approach. Later on in the roll-to-roll biofluidics pilot project, there was the next steps. In this case, in the deliverables were EuroNanoNet, so our company had the pleasure to implement and to conceptualize how to approach the SBD, so the Saved by Design. We started to add, at the same time coming out, so 2015, the UN Sustainable Development Goals. This was more or less, for us, the starting point towards all this second S, so the sustainability S in the SBD. Then we joined via this Sasuke Network, a group with the environmental agency, so EEA, with ECHA, with Sasuke, of course, with academics and government, and created this so-called non-paper. Quick question, who in the room, please raise your hand, knows this non-paper? Okay, 1, 2, 3, at least 3, 4, thank you. Maybe you have a short read on it, and you will find quite a lot of things that are now in the JRC framework. I want to take out one of those points. It's this safe redesign of chemicals and materials, and to ensure that toxicity and other life cycle considerations are integrated into the design process. Which brings me back to Steff and our ideas to the SABATLE project. We wanted to have this included in the production and in the assessment of the components of this redox flow battery, which brought us to this project concept. Later on, 2022, the framework came. And here you will see, this is why I took this nice picture out of the framework, that in our case, we have put this iteration, this impact assessment, and then the iterational things, which the results will then be shown by Steff again, directly into the project, which means we made a kind of reverse engineering without knowing that there will come this framework. Finally, our aim is that we can really show on the one hand in the paper, which is maybe to be submitted next week, hopefully, to contribute to the framework, let's say assessment testing, to put these technical things into the case study collection. And I think to give you more technical input on that, especially on the toxicity parts, solvents and all these parts, I can hand over back to Steff. If it works.
Yeah, it just takes 2.
Ah, yeah. Okay.
Thanks. Microphone is off. Okay. So I think Andreas has already nicely shown that we need these different phases, right? So we have the redesign phase, like where we are checking. I just showed you the synthesis before. So basically that was run in, you do it for a scientific paper. You just try to do your best. But is that best for the environment? Probably not, because you're just thinking about having a nice performance for this scientific paper in a high impact journal. So I just will show you some very brief results on these things. And then, yeah, the one thing was then the sustainability assessment, where I will give you some ideas about the toxicity. So we knew from the very beginning that the thing that we are using is not very toxic, but you need then really to do a lot of more investigations to really prove it, right? Because the chemicals we are using in this battery, they are not listed in the databases. So some of them are or only some properties are listed. So you need to really think about it, like what you said, like how is it for the toxicity, human toxicity, how is it safe, and so on and so forth. What are the exposure scenarios and things like this. This is what we did there. And then we made such feedback loops. But let's jump into it. And I mean, in the beginning, we were like, when we were just thinking about the solvent, we were using like THF, like tetrahydrofurane, and this is considered a really non-sustainable solvent. And why did we use that? Because there's a trick in the synthesis. You start like with a solution of the vanillin, and you add the reagent, which is hydrogen peroxide, so not very, like just oxygen-generating species. And in the course of the reaction, I mean, first it's just one phase, and due to the miscibility gap of the THF and water, it's separating into two phases. This is the elegance of the reaction. So you start with one phase, the continuous reaction. You just have then the water phase, which just contains basically water, and then you have the product phase, where you basically only have the product. And if you replace then the solvent, you might have a problem, right? Because you need to ensure that you have the same behavior. Otherwise, you need to start again from scratch. And we were quite lucky that the 2-methyl THF had the same like behavior. I mean, we had to adapt a bit, but not to a big extent in order to get the same thing, because it's not only about the yield, it's also like about the easiness to separate the thing. And this was our first milestone, because this is basically sustainable. It's considered a sustainable solvent because you can make it from furfuryl alcohol, and this you can also get from biomass, basically in the separation of like in the pulp industry, pulp and paper industry. So in the batch we get more or less the same results as you could find in the paper, but of course for scale up we have designed this continuous process with the phase separation, where you can get like larger than 95. So you ask what are the rest? So this is the oxidized species, which is basically not even a waste material. So basically if you count those two together, we are nearly close to 99%, which is very nice. Then the second thing was we knew that the component, like this component here, like this MHQ, or the oxidized form where you have here two oxygens, so they were not cancerogenic, not mutagenic, they were not teratogenic, they didn't show any thyroid disruptor properties, but we did this ecotoxicity thing. And of course, when you're just thinking about, you have these huge tanks with the liquids standing in the environment, there may be some leakage, at some point. You can never exclude them, even if you have like some safety containers around. I mean, you can never exclude that. And basically, that was like the reason why we also tested the toxicity of this Daphnia. And you can see that's quite toxic for those little guys on the water surface. And we were thinking ourselves also, could we like decrease toxicity without losing performance, basically? And that was maybe one of these first steps. I mean, we did not only use this molecule, we had a couple of iterations, but finally we ended up with this one. When you check the databases, how can you make it less toxic for this? And you end up, okay, let's add some amines on the keynotes. And surprisingly, you can find some data on that is less toxic. And then we were like making this, or selecting this component. It's a very simple reaction, one-pot reaction. You just stir it. You need to have a little bit of ethanol, which is also bio-based, so it's not a reaction in pure water. But then you can get in very high yields this material, and then you see that the EC50 value for the Daphnia was like increasing like by a factor of, I need to calculate, 100,000 or something. Yeah, something like you really have like, you came from like 0.07 nanomoles to basically into the millimolar range. And also like when they start to die, also this concentration was like increased significantly. So this was really a very nice first research, just showing you how this concept that Andreas and his team was like developing back then, it was working, yeah, right? So we did not have a lot of money in this project, but we tried to use it very efficiently by thinking about things. The second thing, life cycle assessment. This is preliminary data, so it's not finished yet. I'm not so optimistic about you about next week, so maybe like mid of July. So basically, when you're thinking about vanillin, so vanillin, it's also used like from synthetic sources. So most of the vanillin nowadays comes from oil industry, basically. So there's like a Guajacol process. You're just manufacturing the vanillin. That was different like 25, 30 years ago, 40 years ago, meanwhile, where most of the vanillin came from wood, basically, from pulp and paper industry. And what we found out basically was, and that was lucky, that the vanillin from lignin is basically more sustainable than if you use it like from fossil-based soil. That's maybe not such a big surprise. But the very interesting thing was that we really need to take care about the energy that we put in. So now we have a better sustainability in terms of the raw material, but we need much more energy. And this is, of course, something that we could not have considered in this phase, because in industry, you can work with heat exchangers. You can really efficiently reuse energy, which you cannot do in the lab so easily in small scale, because it's quite difficult. So this is like an interesting thing. I think we've heard about the fifth pillar, right? So I think there's not too much data, and I show here some data which is maybe quite interesting, because it also shows the difficulty in using this social life cycle assessment. Because the problem for the social life cycle assessment is you need to get the data, and then you get like some interesting results. So I think we use as countries like where vanadium, where you have a lot of vanadium is China, for instance. So there you get the social impacts. And for vanillin from lignin, we used Sweden, the US, and Central Europe, like as countries. And then you see that in most of these social life cycle impact categories, like in 8 out of 10, so this technology is much better. But then there is a really interesting surprise, particularly when you see here, and that's also quite, it was like drawing our attention on it, because this access to hospital beds, Sweden was performing extremely poorly there in this category. And when you look in this, you just see that this obviously, there must be something wrong with the data, right? Or there must be some systemic thing. And then we were talking with another industry partner who used to live in Sweden, because of course we don't know the system here so well. And then he said, yeah, but you know, the system works different in Sweden. So you you don't bring the people to the hospital. You have those health centers where you bring them. And in the US, it's also like this. I mean, there is the access to the hospital bed, but it's very expensive. Yeah. So these are the two things that you really need to consider here in this case, and that makes it very difficult to bring it to the hard fact basis. So I think this is where we really have to work on. And I think that's also what we discussed yesterday in the dinner, or like dinner at the welcome reception. They really need to work on this, and we should really not exclude it, because when you see this now, it's we have much more of these indicators, and for most of them, this is much better if you do that in Europe rather than outside. So what are the limitations now? What have we learned from this? So the first thing was we cannot do that. Right. We had a small project for 2 years. The framework was not even out there, so we made the best out of it. You were just saying it. We were pragmatic. I think we were very pragmatic. So this was the thing. What we learned as a startup, and also like during this, we really need somebody who really knows about the stuff. So I think we should not leave companies alone with this. So we should go to experts and really work together with them. And this should be, maybe you can also like foster that by like mandatory project requirements, that this should be an integral part of it. Yeah, and that really like people need to have a track record on that. Yeah, also this was the nice thing, the social LCA results, that is geographical things, where you do things, that's also important. And where are you doing your things? I think this is also something, it's important, but it's really difficult to grasp it at this stage, because I mean, if we did not have this one person who was living in Sweden, maybe that would have been difficult to interpret the result. I mean, at some point we would have found out, but it's really a difficulty, right? So the systems are different around the world. It doesn't mean that these numbers are like true or wrong or whatsoever. And yeah, what are our recommendations? We really, you need to prioritize on the aspects where you can do something, where you can really make some, like an impact on it, basically. So really specify what you can do. That was like the solvent, this was toxicity, but also, I mean, the matrix was pretty small. Yeah, you need the collaboration, I said that already, and you really need to define these things. And with this, I would like to thank all people who were involved. So these were also like a company from Spain who was like doing all the toxicity assessments, like BioBide, and also like our partner from pulp and paper industry, Mondi. There was the University of Graz who did a lot of the life cycle assessment. Of course, the funders that gave us the money, so FFG and the Sasuke Network and Osalan. And also from the Ecolyte company, we get a lot of other funding. So just recently, we got an ESC Pathfinder where also toxicity and sustainability will be a big issue. So like we reserved about 10% of the project budget, about 450,000 euros just for this part, because I think it's very important to show it that it's sustainable, and not to show it when it's finished, but to show it during the development, because there you can easier interfere into the design process. And with this, I would like to thank you, Andreas, and also Clemens, who is here, and yeah, also the organizers, and yeah, he's here. And yeah, thanks for your attention.
Thank you very much. I think let's just take, we have on my watch 2 minutes left. My watch is not as precise as the computer, but let's take 2 minutes. Are there any questions from the audience here in the room to the battery presentations? Up there.
You need to run.
You answer, I run.
There was one over there. Okay. Thanks a lot for the presentation, and certainly the important topic of batteries. I do have some difficulties to understand the recommendation 3, where you say it's geographically dependent.
Yeah, maybe I was not.
Isn't it more related to the systems which are behind it? So it's more a political or societal issue and not so much geographical?
Yeah. I think that's maybe I did not emphasize that. It also makes a difference where you produce the vanillin from lignin. I forgot to say that. For instance, if you produce vanillin from lignin in China, it's as bad nearly as if you produce it from fossil-based sources. So also this plays a role in there. So I think I forgot to mention that. That was a big surprise to us. So that this production also, like in another country, although it's from bio-based source, gives you a very poor LCA result. You're completely right. Thank you.
Thank you very much for a very nice presentation. It was really nice to see a use of the framework presented here. So I want to applaud you for that.
Thanks.
We tried to use it on smart materials as a broad category. And despite the fact that we were very broad in our search, it was pretty much impossible to find actual information to cover all the different categories that the JRC have suggested. So I was wondering, like, how hard was it for you to find the information you needed? And maybe a misleading question is do you have to be inside the company in order to really use this framework, or can academics like me also use it, you think?
Maybe for the first question, it's extremely hard to get the data. And in some cases, we had the data because we had to measure it. For instance, the energy consumption that we had there. I mean, we had to measure the cooling energy that you really need. You can determine that. You need to do a lot of experiments. You then scale it up and say, okay, but that's really difficult. And the second thing is in the inventories. I think you're referring to that. Like just for lignin production, it's very difficult to find the data. And without the participation of this company, we would not have gotten the data because they are not publicly available. So they don't give you the data. So this also brings us back to FAIR. But I mean, there's no interest in giving because this is kind of a secret, yeah, like a company secret. So this is the other thing. And to your other question, for the academics, I think, yes, the academics, they should be able to use it, I think. And however, you always have experts like Andreas or like other people in this room, like you saw some presentations, who really are used to apply the concept in different contexts. So that was just one example. I think, Andreas, you're like present in many projects and many materials.
Yeah, to add on your second question also, first, it's of course complicated to find your way through. It helps you if you have been involved since 15 years in this shaping of all these SBD, SSbD things, that you a little bit have an idea where is the light at the end of the tunnel. The tricky part was then, together with Steff, to funnel down from the complete part. Okay, what do we have? Because 2019 we had the first idea on. 2020 in January we submitted this proposal. So we had no idea about there comes a framework in the future. So 3 years before the framework was out, or 2.5 years, we had no idea about that, but we had an idea about what we want to achieve with our ideas, with our concept, to make it more sustainable, more safe, and to make a difference with it. Then, when the framework came out, we sat down again, funneling down process. So what have we had in our concept? And I showed this picture with our concept, with the, let's say, a little bit different named, but more or less the same. And then pointed out also for the day, okay, this feeds into that part of the framework, or vice versa. The framework is addressed with this or that tests, data, and so on. But this process needed more discussions with the technical expert, and let's say with our side, with BNN team, to find out, okay, these are the aspects that are relevant from the SSbD framework to step forward. And of course, we miss out a lot of other parts, and we'll try to feed it into the case study template, that there can be a next step, and that also SMEs start thinking about, okay, if one has done it in a certain way, definitely not complete, but why not starting it now and not waiting for a longer time, and then finding out, okay, they're coming in experts, there will be more and more skilled people around us, so education is an extremely important part, which is addressed, for example, from the nano safety cluster. So please have a look on that. You will find there the training and education part, which is extremely strong, and also downstairs in the room, methods and technologies from EU-funded projects are presented on the SSbD. So not only the concept itself, but also some methodologies that are available in those projects. So maybe this helps and answers your question.
You know that we're working on to build an SSbD network. How can we support you? What do you need from experts as an SME? What would be useful? What could be maybe one or two lessons learned that you can say, if I had access to such a network, if you didn't have Andreas, what could be the things that you need that we can support you as a network, or we can support SMEs?
I think it's particularly the regulatory framework, like that comes actually afterwards, as we learned. So you have like the SSbD, but also you need to think about what do you need to be prepared, even if I have this, right? I need to go to a certified lab at some point, but how long can I do it without doing so, yeah? So what are the critical steps? Can you help us identifying potential problems in this battery system or battery ecosystem, which is different to lithium-ion batteries? Not so many people work in that. So these are the things, because it's very difficult. I mean, it's anyhow very complex with terms of regulation and things like this. And I think we were just touching a few things. I mean, these exposure scenarios, dangers for the workers in the plants. I think we skipped that in the end because it was way too far from reality. But I think just to get like sensitized, I think this is like maybe doing some workshops. This is what we would be much interested in, also like in a follow-up project. That some experts come and we discuss, and I think that's something we should anyhow do, right, Andreas?
Okay, so thank you for everybody who stayed also now for the discussions. Thank you very much for all the speakers. I think it was very nice presentations. And I hope that you all take home that actually, we're triggering your thinking and we're triggering your learning, and you can have, new skills, new questions, and that we hope that it will, help us to stay in our planetary boundaries at the end of the day. So thank you very much.